Okay, this is going to be a BoF. Everybody who doesn't care about what they do in 20 years, you can leave the room. Just the very brief summary. Time is running out. January 2038 is when most of your existing computers will stop working, and that can include your car, and any kinds of electronics you're buying today or within the next few years, and we have to solve that. We have three major areas that we're working on. I'm working on the kernel. I've been doing this with John and a few others during the last maybe 5 years. It's been that long, I think. So we're slowly working our way through the kernel, converting 32-bit timestamps into 64-bit timestamps everywhere inside of the kernel, and in some cases on the interface between kernel and user space. We have a plan for the interface to user space. We have not really started getting that upstream, but one syscall just made it in, the statx. We have 22 other syscalls that we need to get in, and then write emulation for a number of other syscalls. We've had the patches for years now, but we have to keep the ball rolling there. The second area is glibc. There's been a lot of work on glibc in the past year. The plan for glibc is to be fully backwards compatible, to have a glibc that just adds new functionality, leaves everything in there. You can build against 32-bit timestamps or 64-bit timestamps when you're compiling a program as a compile time option. You can run code with 64-bit timestamps on old kernels that do not have native support for that. There will be a few bugs, but the idea is, the principle in glibc is we're only adding features and we're trying to make it work whenever we can. That's what the glibc folks are doing. Once we have kernel and glibc, we can look at the whole picture and do distribution builds. Most distributions that most distributions that are for like desktop style, you have Red Hat, SUSE, and so on, they will probably just not support anything 32-bit in 2038. So they do not have to solve this problem. Debian probably will, which will be painful for Debian to do the conversion because you have to rebuild every package, but not break anything in the process. So you have to have an upgrade strategy so you can update to the latest library version of any package without breaking anything that relies on it. So any interface that is provided by a library must not break applications that are not updated at the same time. You can do a full rebuild. We've done this going from ARM to ARM-HF. Nobody wants to do that again, but that would be the solution that we know works. So we could have a new distro target that works. ARM60, yes, sure. The problem, why we even care about this is there is source code out there that is not 64-bit clean that people will be deploying over the next 5 to 10 to 15 years, possibly later, and people will expect that to keep working. They might not have 32-bit CPUs, but they will still be running this code on 64-bit processors. So we have to have a way to have user space binaries. You might have a container running your RHEL 3 release that you expect to run in 2038. It won't. But people are doing crazy things, and we need to help them as far as possible.
So you've already got people going.
Yep.
Yeah. You've already got people going through fixing up kernel interfaces. Has anybody started scanning through userland packages yet?
No, not that I'm aware of. So the plan for that is basically to do a rebuild of a source distribution like OpenWRT or any of the others. You build everything 64-bit and you see what breaks. The most important case for this obviously is cars, because they tend to be the things that hang around. Mobile phone, either your flash breaks or your battery breaks. Either way, it doesn't survive that long. So that's not a problem. But there are lots of other devices. When you can buy wireless cameras today that have a 10-year-old kernel. In 10 years, you will still be able to buy cameras that have a 12-year-old kernel. You might want to use them for a couple of years.
There's a lot of infrastructure as well.
Yeah.
They talk about sprinkler systems for buildings and that sort of thing.
It's going to be the stuff embedded in your washing machine and stuff
Yep.
like that people will still be running on a 32-bit device in 25 years, and we know it will break.
Yes, exactly. There are, even on a 64-bit system, when everything is 64-bit, we have problems that we know we have to solve. The CPIO file format is broken. People are using it. RPM depends on it. NTP, I think, is broken.
It's not on the same day, but
Okay. Yep. ext3 is broken, the file system. NFSv3 is broken. In most cases, you have an upgrade path, so NFSv4 is okay. ext4 file system is okay. XFS today is broken. We know how to fix it in a compatible way. But there are things we know about, and then there are things we don't know about that even on a pure 64-bit we have to fix inside of the kernel, in user space, in any kind of in-house application that people build from their own sources. Someone else should talk a little bit. Who has an opinion on this?
So do we have any way of getting tools to help with this, all the things we can do with GCC or Clang, which will help, if spotting people assigning time T to, 32-bit 32-bit integers, that kind of thing?
So I can tell about what I'm doing for the kernel, what tools I'm using there that might or might not apply to the user space. So what I'm doing in the kernel is that we defined new types, time 64T, time spec 64, and so on. And I have a kernel tree in which I removed the definition for time T and time spec, made them completely invisible, just to guarantee that I am using all the new types everywhere. And whenever I fix something to use the other types, I make sure that I see where variables are being assigned, and if it's being assigned to another 32-bit type, then I try to come up with a plan.
you do it manually, right?
That's a purely manual process. So I'm building things. I'm building all yes config. I'm building rand configs to see what breaks.
Yes, the trace from, you have a variable analysis of the guarantee.
Yes, tracing the variables is all manual. Yes.
That's manual.
Yes.
Tools, they would be really, really helpful.
Yep.
I do agree. Similar to how you have the pointer cast thing, where you cast the pointer to an integer.
Shouldn't something like Sparse be able to help with
Sparse
this?
should be able to help with this, yes. Or GCC plugin could help with this.
Yeah.
Same thing. GCC plugin might be easier. Basically, nowadays, I think with GCC plugins, you can do everything that we're doing with Sparse. We just haven't done it yet. But someone could make a GCC plugin that checks for time T.
Any friendly toolchain people who'd like to chime in? I guess not.
Yep.
So how is your project going to get to fix the kernel up? I've seen lots and lots of traffic on the list, and there's a few new people who are going through, and it's a lovely project to get new people involved. How is that going so far?
So right now, there's one person doing most of the work. That's not me. That's Deepa Demanami, who was my intern in Outreachy last year, and she's still working on it. We have regular meetings. We talk about what we're doing. She has all the patches for VFS, which is one of the hardest problem. Trying to trickle them into the kernel, it takes a while. She has a plan for syscalls, not quite the way that I have my old patches, but better. She has a plan. We have a plan together for how to address the set sockops interfaces, which don't go through glibc. We have to fix them independently, and I think we have a good plan there. I think we have, I'm not sure what the status is. We had patches for device mapper and input layer that may or may not have been merged. I'm not completely sure about the status of that. We have, I had a patch for video for Linux that got rejected at the time. We have to follow up on that again, probably with a new approach. We have to do something similar in audio. Those are the main subsystems that I can think of right now that have interfaces to user space. We have a couple of things inside of the kernel that don't have interfaces, that take more than trivial patches. That would be, for example, the key management, and the real-time clocks. And some work has been done on both of those already, but we have to complete those things. And then probably do a pass of just flushing the time T out of all the common timekeeping code once we have the sys, like all the way to the syscalls, and then do the syscalls, just to keep the old interfaces basically in one separate header that you only have to include if you actually need the old stuff. And then we can make that header file optional for people that actually want to build a kernel that is known not to break in 2038. We will put an error in there, in that file. If you ever include that file in anything you build, then you don't get a kernel.
What about out of 3 sources drivers?
So out of 3 drivers is fairly easy once we have made the time spec and time T optional. If you have a configuration where you turn those definitions off, they stop building. If you leave them on, you can build kernels that will break in 2038. At some point before 2038, we will completely remove those definitions.
So I've registered a session to talk about this more from the userland side for DebConf.
Thank you.
Which will be in Montreal in August. As well as going through, as you say, describing just a source distro, it will be nice to actually scan through the Debian archive and start seeing what things are going to break there as well. That's going to take quite a while, so the sooner we start, the better.
Yep. FreeBSD, I actually checked, and FreeBSD doesn't seem to have done it. NetBSD and OpenBSD have done it. I don't think that helped that much. So they took different approaches. One of the two just changed the type and rebuilt everything, and the other one actually made it backwards compatible at runtime, but not compile time. We're having a much harder time in Linux, mainly because we are keeping the compile time interfaces working. So we don't have to break anything by upgrading the kernel or the glibc, which is not what the BSDs did.
But I guess applications that have been tested at least in the new world.
Yep. Yes, a lot of applications that have had bugs are probably fixed, but it's not clear to what degree, because the degree of testing that have done with timestamps beyond 2038 may have been very small. Okay, so, and we're almost out of time. So in 5 minutes, I think there's the closing keynote in the keynote room, and then there's the demo Friday. So thanks for coming here to my session.